Alright guys, we're going to look at two specific examples for geometric sequences. So the first one, we are given a term and the common ratio, and we're asked to write a rule for the nth term. Now what this means when they say write a rule for the nth term, this means an explicit formula. So we're going to be using the formula a sub n equals a sub 1 times r to the n minus 1. Now, we don't know the first term, but we can use these two pieces of information to find it. So if we fill in what we know, right now we know that a sub n equals the first term times 2 to the n minus 1. Our challenge here is finding the first term. But because we know the fourth term, we can figure this out. So because a sub 4 equals a sub 1 times 2 to the 4 minus 1 power, well, we know what this a sub 4 equals. It equals 12. So 12 equals the first term times 2 to the third power. And now we have this equation. And notice it's actually a linear equation. So we can divide both sides by 8 to find that first term. So 12 divided by 8 is going to be 3 halves. So our first term is 3 halves, which means our formula would be a sub n equals 3 halves times 2 to the n minus 1 power. Now you could have figured out the first term by working backwards, but this is just a more efficient way, especially if you had maybe they gave us the 20th term instead of the 4th term. The other thing is go ahead and check it. Plug in 4. 2 to the 4th minus 1 is 2 cubed. 8 times 3 halves is 12. You can make sure that your rule actually works. So now we want to come over here and we want to graph the sequence. In order to graph the sequence, remember we start at 1 because we talk about the first term. And remember, this is going to be a discrete graph. So I'm going to make a table, and I'll make it just a little bit easier to see those values. So we know the first term is 3 halves. We also know the fourth term was 12. Those are two pieces we already know. Now, we could plug in these other values for n and calculate using the equation, or we could just use the fact that the common ratio is 2 and multiply by 2 to get the next term. So the second term, 3 halves times 2 would be 3. 3 times 2 would be 6. 6 times 2 is 12. 12 times 2 is 24, and 24 times 2 is 48. Now, the question usually happens, how many terms should you give? Usually the directions will tell you to give the first 5 terms of the sequence or the first 7. In this case, I simply followed what I had on my graph. So notice here that my n values go to 6. So I figured I would go ahead and go to 6. So remember, this is n and this is a sub n. Please be careful as we are scaling our y-axis as well by tens. So we need to now graph these points. So 1 3 halves is going to be really down here close to the x-axis. 2 3 is not too much further. 3 6. 4 12. And so on. And notice this is not like our arithmetic sequence. Our arithmetic sequence was a linear equation. It had a line. This one is exponential. It has this curve. Okay, now again, we're not going to draw the curve in. We're going to leave it discrete, but know that it's just going to continue growing very quickly. Now, because this is not an arithmetic, it does create a problem when we don't know the common ratio. So for example, in the second problem, 2 terms are given. Find the rule for the nth term. They don't tell us the first term, they don't tell us the common ratio. And then we can't figure this out using slope because this isn't a line. If you were to look at different distances, so for example, if we were going to do the slope between 2 and 3 would not be the same as the slope between 2 and 5. They would be very different. The average rate of change would be different. So instead, we're going to have to use our formula. So remember, our formula again is a sub n equals the first term times r to the n minus 1. Now again, we have an issue because 2 of our unknowns, the 2 we need to know, a sub 1 and r, are not there. And you might say, well, we could just divide 3072 by negative 48. Well, that's a good idea, but the problem is that when we're doing our ratio, remember it's the term after it divided by the term. Okay, so we don't have 6 doesn't follow 3. Now, if we had the third term and the fourth term, you could absolutely do this. If we had the fifth term and the sixth term, you could absolutely divide and figure out that common ratio. But we don't have that. So what we're going to do is we're going to fill in what we know. So because we know a sub 3 equals negative 48 and we know a sub 6 equals 3072, we're going to use the bigger term, a sub 6. And we're going to say instead of a sub 1, we're going to put a sub 3. Okay, so we're going to write a sub 6 in terms of a sub 3. Now, where we have to be careful is that because we changed the n, this n is a 6, this n here, this n right here also has to become a 6. Okay, because we changed this 1 here, whoops, to a 3, sorry guys, my computer's being a little fussy. This 1 became a 3, we must also change the 3, this 1 up here, to a 3. Okay, so we're going to have 6 minus 3 in our formula. So a sub 6 equals a sub 3 times r to the 6 minus 3. We simply changed our numbers. And remember, the bigger term, the further term away from 1 goes into a sub n. The closer term to 1 is going to go in for 1. So instead of a sub 1, we're going to do a sub 3. So now we're going to fill in what we know. So we know a sub 6 is 3072. We know a sub 3 is negative 48. Then times r to the third power. Now, this is a power equation, so we can solve this. So we're going to start by dividing by negative 48. Okay, so when we divide this by negative 48, we end up with negative 64. And this equals r cubed. And then remember, we're going to take the cubed root of negative 64. Now, because this is an odd power, we don't need absolute value bars. So we're just going to say r equals, and then the cube root of negative 64 would be negative 4. So now we know that our common ratio is negative 4, and we should have anticipated our ratio being negative because notice these terms, one's negative and one's positive, which tells me I have this alternating pattern. So now I know that a sub n equals a sub 1 times negative 4 to the n minus 1. So now, how are we going to find the first term? Well, the same way we did it on number 1. We're going to plug in one of these terms. So because this one is smaller, I like to go with the smaller one, but it really doesn't matter which one you choose. I'm going to say a sub 3 equals a sub 1 times negative 4 to the n minus 1. Well, a sub 3 is negative 48. I don't know a sub 1, but I do know the n here is 3. Okay, so really I should have made this guy up here 3 as well. So now I have negative 48 equals a sub 1 times negative 4 squared. So negative 4 squared, of course, is 16. So when we divide by 16, negative 48 divided by 16 is negative 3. So a sub 1 equals negative 3, which means our formula would be a sub n equals negative 3 times our ratio negative 4 to the n minus 1. Okay, so we found both pieces that we needed to write our equation for the nth term. Now, I would definitely tell you to check this one, okay, because if you make any mistake anywhere, you're going to know. So if you were to plug in 3 for this, negative 3 times negative 4 squared, does that equal negative 48? And in this case, it does. Same thing with a sub 6. Plug it in and see if you're getting those answers. You could also start by listing out the first few terms. So negative 3 times 4 is 12. 12 times negative 4 is negative 48. Oh, that's a check. Keep going. Negative 48 times negative 4 would be 192. 192 times negative 4 would be negative 768. And then times negative 4 again would be 3072. So we can see that we did get the right sequence with this particular rule. There's only one rule that works.